look at the Google strength in GCP now, Google's cloud product, where they have a completely fully served enterprise offering for essentially automating your company with AI.
Yeah.
And the remarkable thing, and this is, to me, is shocking, is you can, in an enterprise, write the task that you want, and then using something called the Model Context Protocol, you can connect your databases to that, and the large language model can produce the code for your enterprise. Now, there's 100,000 enterprise software companies, middleware companies that grew up in the last 30 years that I've been working on this that are all now in trouble because that interstitial connection is no longer needed.
What's their business?
And of course, they'll have to change as well. The good news for them is enterprises make these changes very slowly. If you built a brand new enterprise architecture for ERP and MRP, you would be highly tempted to not use any of the ERP or MRP suppliers, but instead use open source libraries, build essentially use BigQuery or the equivalent from Amazon, which is Redshift, and essentially build that architecture, and it gives you infinite flexibility, and the computer system writes most of the code. Yep. Now, programmers don't go away at the moment. It's pretty clear that junior programmers go away, the sort of journeyman, if you will, of the stereotype, because these systems aren't good enough yet to automatically write all the code. They need very senior computer scientists, computer engineers who are watching it. That will eventually go away. Yeah. One of the things to say about productivity, and I call this the San Francisco consensus because it's largely the view of people who operate in San Francisco, goes something like this. We're just about to the point where we can do two things that are shocking. The first is we can replace most programming tasks by computers, and we can replace most mathematical tasks by computers. Now you sit there and you go, why? Well, if you think about programming and math, they have limited language sets compared to human language. Yeah. So they're simpler computationally, and they're scale-free. You can just do it and do it and do it with more electricity. You don't need data. You don't need real-world input. You don't need telemetry. You don't need sensors. Yeah. So it's likely, in my opinion, that you're going to see world-class mathematicians emerge in the next 1 year that are AI-based, and world-class programmers that are going to appear within the next 1 or 2 years. When those things are deployed at scale, remember, math and programming are the basis of kind of everything, right? Yep. It's an accelerant for physics, chemistry, biology, material science. So going back to things like climate change, can you imagine if we, and this goes back to your original argument, Peter, imagine if we can accelerate the discoveries of the new materials that allow us to deal with a carbonized world. Right. It's very exciting.